If you're good with solving simultaneous equations and you're used to it, you've probably only done linear simultaneous equations. So these are where x and y only have a power of 1. But the next step is to be able to solve a non-linear simultaneous equation. So this is where you have one of the equations is a linear equation, so something you're used to, and then the other has one of the variables to the power. Now, usually, and that's in most cases, you will have x raised to the power and y is the normal one. So the steps I'm going to do, or the steps you're going to do for every nonlinear simultaneous equation is typically the same, assuming that x is the one raised to the power and y is the other variable. If it's switched, if it's y that's raised to the power of 2, then you just switch the steps that I'm going to tell you. So I'm going to keep on writing the steps as we move through the process. This is a bit of a, not a tricky example, but it just involves more algebra than easier questions, but the process is still the same. So what you want to do with non-simultaneous equations is use the substitution method, and to be able to use the substitution method you need to make the subjects the same. So first you're going to make y the subject, and the reason we're picking y is because for the quadratic, y is already the subject. If it wasn't, if it was something like this was 0 and it was, for example, negative y, then make y the subject, because when you're dealing with quadratics, this is what you're used to seeing. So change it to a form that you're used to seeing. So most of the time it's already ready for you, so you don't have to worry about that, but this is just to help you with any type of equation you might come across. So since our quadratic has y the subject, then I will make the other one with y the subject as well. So you want to make both equations have y the subject, or make them have the same subject of both. So I don't need to change this, but I have to change this. So if I make y the subject here, it's going to be y equals to 3x plus 1 divided by 2. Now you can simplify this if you want to, so 3x over 2 plus 1 over 2 if you want to, but let's just leave it there. Then you're going to equate the equations. So what does that mean? Well, notice how you now have two ways of representing y, or talking about y. First of all, y is equal to 3x over 2, 3x plus 1 over 2. Also, y is equal to 2x squared minus 4x plus 3. So I have two ways of talking about y, but they're the same y. Y is this, and also y is this. So they should be the same thing. If y is equal to this and y is equal to that, then these two should be equal to each other. So that's it. That's the next step that you're going to do. Once you've made y the subject, you're going to make these two equal to each other, because this is y and this is y. So they should be the same. Now, once you've done that, what you want to do is, well, this is good. I have everything in terms of x, so you will simplify and change it to a quadratic equation. So simplify and to a quadratic equation. And remember, a quadratic equation is something where you have ax squared plus bx plus c equals to 0. So something with x's and then equal to 0. So the way you do it, well, I first need to get rid of this divide by 2. So this is where I said the algebra is weird in this question. I'm dividing by 2 here, so to get rid of it, I'll just multiply by 2 on both sides. Or you can think about it as a cross multiply, but be careful, you need to multiply this whole thing by 2 to get rid of this divide by 2. So the divide by 2 gets removed here, and what happens is it becomes a multiply by 2 here, but remember you multiply by everything. So multiply out, I'm gonna get 4x squared minus 8x plus 6. And then just rearrange everything. I'm going to move everything to the other side to make it equal to 0. So in this case, I'm going to get 11x plus 5, minus 11x plus 5. So this is my quadratic equation, and you can either solve it using the quadratic formula or factorization. For this question, you will need the quadratic formula, but I'm not going to go through the process of solving it. But what you're going to get is x is equal to 0.57 or x is equal to 2.18. These are my rounded answers to 2 decimal places, and the next step you're going to do is to try to find y. But when you're trying to find y, use the full calculator answer that you're going to get, so the more decimal places, because it's going to give you a more accurate answer. But if you're writing the final answer down, it's okay to just leave it to a rounded form. So what I have is 2x solutions. Usually in simultaneous equations, you end up getting the x and then you just substitute it in the equation to get the y. We're going to do the same thing, but we're going to repeat it twice this time. So I have x equals to 0.57. I'm going to substitute it into one of my equations, exactly as you do with simultaneous equations. The easier one to substitute in is usually your linear one. So I'm just going to substitute in here. It should give you the same answer if you substitute it into this one as well. So I'm not going to go through the process of substitution, so just plug it into your, so I'm just going to write dot, dot, dot to show you that I'm putting the full calculator answer, and divide by 2, and so on. So for this x, I'm going to get a y as 1.36, and for this x, if I repeat the same thing, I'm going to get this y. So your solutions are x equals to 0.57, and with it comes y equals to 1.36, and you have and or, it doesn't matter. Usually we write and for these, and it's this. So we have these two solutions. What does this actually look like? So you're used to only getting one answer for simultaneous equations. For quadratic, so what you have is one is a linear line and one is a quadratic. So the quadratic is actually, this is your quadratic. So this is this equation. And then our linear line was this one. And what our equation did, what the simultaneous means, is that I need an x and a y coordinate that I could substitute in here and substitute in here, and it would work in both. And these coordinates that we got are precisely this point and this point. So this x and this y, this x and this y. So this is just extra information just to show you what it actually looks like. But the process is still the same. So you make y the subject of both, make the equations equal to each other. So as soon as you make y the subject, simplify it to a quadratic equation, so something equal to 0. So solve the quadratic, and then your final step is substitute each x in the original to get y, and those would be your solutions.